Okay, so this is the first part of our review for Chapter 1B. I'm going to go through the first page, front and back, so you guys can check your work. So the first one says, Miss Morgan is at the store buying chicken salad for her lunch. She finds a 12-ounce container for $6.05 and a giant 40-ounce container for $20.50. And we want you to round to the nearest cent. So first, it says, what is the unit rate for the smaller container? A unit rate means there's a 1 in the denominator. So we want to find the unit price of the small container. Up here it says the small container is 12 ounces for $6.05. Let me fix that. All right. So we need to find the unit rate using that amount. So we should have money on top, ounces on the bottom, because we want to find a unit rate. It's telling us to round to the nearest cent, so we need to find the price per ounce. So you get $6.05 all over 12 ounces. You plug that into your calculator, and you get 0.50, so 50 cents per 1 ounce. That's the answer you're going to write in the answer line. So 50 cents per 1 ounce. All right, so B, we also have to find a unit rate, but now we're doing it for the large container. So we have the 40-ounce container that was $20.50. So we're going to come down here, do $20 over 50 cents, all over 40 ounces. So do this division, and you get 51 cents per 1 ounce. So that's our answer. So 51 cents per 1 ounce for the large container. So now it says, which container is the better buy? We would say that the small container is the better buy because it's 1 cent less than the larger container per ounce. So that was problem number 1. All right, next problem. These are some of the more challenging problems. These are the conversion problems, so you must show your conversion work to get full credit like we have in class. So looking at the first one, it says Mr. Kellenberger is driving his car down the freeway at 55 miles per hour. So that's what I'm going to start with, 55 miles over 1 hour. It says, what is the car's speed in feet per second? So now I have to go from miles per hour to feet per second. So I'm going to write a little note. Miles over hour to feet per second. So to go from miles to feet, we have one conversion factor. In your conversion factors, you should always have a 1. So looking at this, I'm going to put miles on the bottom because I want them to cross cancel with 55 miles at the top. And 1 mile has 5,280 feet. That works out nice because miles cancels out and feet are left with feet. So we've gone from miles to feet, but now we need to go from hours to seconds. So to go from hours to seconds, we have to go from hours to minutes, and then from minutes to seconds. So I'm going to multiply by another fraction, and I have hours in the bottom over here. So I'm going to put 1 hour in the top, so it cross cancels, and 60 minutes in the denominator. So again, this works out nice. Hours cancel. Now we're in minutes. We're going to go from minutes to seconds. So I'm going to put 1 minute on top and 60 seconds on the bottom because those are equivalent. And those cancel out nicely. Minutes, minutes. We're left with seconds in the denominator. That's what we wanted. Seconds in the denominator. So from here, you need to multiply straight across the top. So straight across the top, and then straight across the bottom. So 55 times 5,280, you get 290,400 all over 3,600. And now we're in feet per second. So when you do that division, your answer comes out to be 80.7 feet per second. Okay, I showed all my conversion work. So this first one took me from miles to feet, and the second two took me from hours to seconds. Good. All right, number 3. It says, show how to convert 9 gallons per second into quarts per minute, and we have to show our conversions. So what we're going to do, we're going to write down what we start with. We have 9 gallons per 1 second. So I'm going from gallons per second to quarts per minute. So first, I'm going to change gallons to quarts. So that means I have to have gallons on the bottom and quarts on top because I want gallons to cancel out. So 1 gallon has 4 quarts, and that's our conversion factor. So we're now in quarts, which is great. Now we need to convert from seconds to minutes. So I'm going to multiply by the conversion factor to go from seconds to minutes. So I want seconds at the top and minutes at the bottom, so seconds cancels out. So I have 60 seconds in 1 minute. Again, our conversion factors should always have a 1 in them. Then our seconds cancel nicely, and you multiply across the top. So we have 9 times 4 times 60, which is 2,160 over 1 times 1 times 1, which is 1. And our new units are quarts per minute. So then you have your answer. There's no division to do in this one, so you get 2,160 quarts per minute. So in this case, you had 2 conversion factors. 1 to go from gallons to quarts, and 1 to go from seconds to minutes. So we're going to use the same method for number 4. In number 4, we have 25 miles per 1 gallon. And we want to go from miles per gallon to kilometers per liter. So I am first going to go from miles to kilometers. So you use your orange sheet and you find that you have a conversion. I'm going to put miles in the denominator because I want it to cancel with the miles in the numerator, and I'm going to put kilometers on top. So I'm going to have 1.609 kilometers is equal to 1 mile. All right. Then that got me into kilometers, which is good. So we did the top. Now we need to go from gallons to liters. So I'm going to multiply by a conversion that will let me cross out gallons and end up in liters. 1 gallon has 3.785 liters. So again, gallons will cancel nicely. And we are going to multiply straight across the top. we get 40.225 kilometers all over 3.785 liters. You do the division and you get a roundabout answer of 10.6 kilometers per liter. Remember, we want these units to cancel out until we end up with our end goal. All right, so next page. For 5 through 7, we're going to focus on cross multiplying. So we call that cross products. So you're going to cross multiply. So I get 8F is equal to 3 times 24. So that means 8F is equal to 72. I divide both sides by 8, and I get that F is equal to 9. So I come over here, F equals 9. All right, the second one, we have to remember, we have to use parentheses because there's more than one term. So put your parentheses and then start to cross multiply. You get 3 times 15 minus B equals 6 times negative 2. We get negative 12. So I have to distribute. I get 45 minus 3B is equal to negative 12. Subtract 45 from both sides to end up with negative 3B is equal to negative 57. I divide both sides by negative 3 to get B alone. So I end up with B is equal to a positive 19. Remember, a negative over a negative gives you a positive. So B equals 19. So for the last one, we definitely need parentheses in this. So we have parentheses around the ones that have more than one term in them. So we continue. We keep on cross multiplying. So we're going to cross multiply, and we get 4 times 2n plus 1 equals 5 times n plus 2. Don't forget, we have to distribute. So we distribute, and we get 8n plus 4 equals 5n plus 10. I am going to subtract 5n from both sides to get all my n's on one side. So I end up with 3n plus 4 is equal to 10. I have to subtract 4 from both sides. Remember, our goal is to isolate n. So we get 3n equals 6. We divide both sides by 3 to get n alone. And we get n is equal to 2. And our final answer goes on the line. N equals 2. So now we have a word problem. So for this word problem, for the following situation, A says write a proportion that you would use to solve the problem, and B, solve the proportion. So just like in class, we need to write a proportion to solve this. It says, Eric is planning to bake approximately 305 cookies. So I'm going to write that down. That's important information. I'm going to use C to represent cookies. If 3 pounds of cookie dough makes 96 cookies, how many pounds of cookie dough should he make? All right, so we have a ratio. We have that 3 pounds of cookie dough makes 96 cookies. So I have that 3 pounds of cookie dough makes 96 cookies. So if I'm writing a ratio, I need an equal sign, and I need another proportion that is consistent with the one we started with. So if I have pounds on top over here, I need pounds on top over here. So pounds. But we don't know how many pounds, so we're going to put X. And then I have 96 cookies on the bottom over here. So I need cookies on the bottom over here. He said he was planning on making 305 cookies. So 305 C. So you have now set up your proportion. It is okay if you had your proportion flipped compared to mine. You could have had 96 over 3 is equal to 305 over x, as long as you are consistent with what is on each side. So to solve, we're going to cross multiply, and we get 3 times 305 is 915. We get 96 times x, which is 96x. We have to get x alone, so we divide by 96. And we find that x equals, or is approximately, we should say, 9.53. But we let x stand for something that was talking about pounds. So we're going to round. X is about 9.5 pounds. So this answer goes here. Whatever proportion you used goes on part A. And you are done. So again, use the methods that we were showing in class to ensure that you're getting the correct answer. I'm grading you on how well you know the processes we taught in class. Lastly, we have solve each inequality or compound inequality and graph the solutions on a number line. So let's start with the first one. Our goal is to isolate n. So we're going to start by adding 3 to both sides. And you are left with 4n is greater than or equal to 180. Just like solving an equation, we have to get n alone. So we divide both sides by 4. And I get n is greater than or equal to 27. So I'll write that on this line. N is greater than or equal to 27. So I'm going to put a 0 and a 27 on my number line. I should have a closed circle because it's greater than or equal to on the 27. And it's saying n is greater than or equal to 27. So if it's greater than, I'm going to shake to the right because the numbers get bigger if you go to the right on a number line. And that answer is complete. So we're going to keep using that process on each one of these. So first we have to distribute 2. So we get 2k plus 8 minus 3k is less than or equal to 14. On the left side, we need to combine like terms. We have positive 2k and positive 3k. When you combine those, you get a negative k plus 8. All right, your negative takes over here. Is less than or equal to 14. I'm going to subtract 8 from both sides. I get negative k is less than or equal to 6. This is like a secret negative 1 right here. We can't have a negative variable, so we have to divide both sides by a negative 1. But when we divide by a negative, we flip the sign. So we get a positive k finally, but we have to flip the sign, and then we get 6 divided by a negative 1, which gives us a negative 6. So I have k is greater than or equal to negative 6. So I'm going to mark 0. I'm going to mark negative 6. I have a solid dot on negative 6 because it could actually equal negative 6. And k is greater than or equal to negative 6. So all the numbers that are greater than negative 6 are to the right. So those are numbers like negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. So remember, if we're going to the right, we're shading numbers greater than. If we're going to the left, we're shading numbers less than. And we have the last problem. So we're going to start again. We have to distribute. 2n minus 6 is less than negative 13 plus 2n. I'm going to get all my n's to one side, so I'm going to subtract 2n. Subtract 2n. And I'm left with negative 6 is less than negative 13. Is this statement ever true? Is this ever true? No. Negative 6 is not less than negative 13. Negative 6 is greater than negative 13. So this is a false statement. When we have something that's a false statement, we say that it is no solution. So over here, we write no solution. And we don't have to graph anything because we can't. There's no way to graph a no solution because no numbers will work to make this true. So that was the first page of the study guide, front and back. Hopefully this helps out a little bit.